Hello everyone, Chapter 3, Polynomial Functions, Graphs and Zeros, Section 3.1, Quadratic Functions. Example 1, describe how the graphs of the following quadratic functions are related to the graph of y equals x squared. So we are going to compare f of x equals 1/3 x squared to y equals x squared, and g of x equals 2x squared to y equals x squared. So here we have y equals x squared here in blue in both of these. This is f of x equals 1/3 x. This is g of x equals 2x. We can see here f of x is wider. And we can see here g of x is more narrow. All right, notes that if we add or subtract something inside of the function, that's a horizontal shift. If we add or subtract something outside of the function, that's a vertical shift. And if we put negative out in front, that's going to be a reflection. Note that your vertical shifts are intuitive. Positive goes up, negative goes down. Your horizontal shifts are counterintuitive. Positives go left, negatives go right. So, example 2, describe how the graphs of the following quadratic functions are related to the graph of y equals x squared. So, when we add 1, it's going to shift up and be reflected. What type of a reflection is it? It's a reflection in the x-axis. Reflected in the x-axis and vertical shift up 1 unit. All right, part B. Here we have a horizontal shift, and again, this is the counterintuitive one, so this is going to go left 2 spaces, down 3. So horizontal shift left 2 units, and vertical shift down 3 units. We have standard form and vertex form for equations. Vertex form, which is called standard form in our pre-calc book. I'm not sure why. This is vertex form. F of x equals a x minus h squared plus k, where h comma k is our vertex. This is standard or general form, ax squared plus bx plus c. Okay. So example 3, write the quadratic function in vertex form, describe the graph. So in order to do this, we're going to have to complete the square so that we can get this into this form. Okay, so to complete the square, I'm going to factor out the 2 plus 4x plus blank plus 7. We have to figure out what to put in here so that this will become a perfect square trinomial that will factor down into something like this. It might be a plus h or a minus h. If I'm adding something inside here, I'm going to have to also subtract 2 times that something out here. So, what am I adding in? Well, we take the b, divide it by 2, and then square it. So I'm adding in 8, I also need to subtract 8. 2 minus 1. This factors into an x minus 2, plus 2, sorry, and then minus 1. So let's describe the graph. The 2 makes it a little more narrow. A equals 2 makes the graph more narrow. And the vertex is -2, comma, -1, which is a horizontal shift left 2 units, vertical shift down 1 unit, and it is not reflected. It is a U shape pointed up. So, pointed up. All right, we're going to do the same thing here. Write the quadratic function in vertex form. Now, I could complete the square again on example 4, but I'm going to use this, -b/2a, and then f of -b/2a. Again, the -b/2a comes from completing the square. It's the same process. It's just a little bit easier to visualize this one. So let's find our vertex, the x component of the vertex, which is h, equals -b/2a, which is -6 over 2 times -1, which is 6 over 2, or 3. So h is 3. To find k equals f of 3, or f of h. F of h, which is equal to f of 3, which is equal to -3 squared plus 6 times 3 minus 8, -9 plus 18 minus 8. That's 9 minus 8 is going to be 1. So we have a vertex of 3, 1. And when we put that into vertex form, we already know that a is -1. Okay, so f of x equals -x minus 3 squared plus 1. That is the vertex form. Describe the graph, again, reflected in the x-axis. In the x-axis, horizontal shift, right 3 units, vertical shift, up 1 unit. That's example 4. Example 5. Write the quadratic function in vertex form. Again, I'm going to use that -b/2a. So h equals -6 over 2 times 5, or -3 fifths. K is equal to f of negative 3 fifths, which equals 5 times negative 3 fifths squared plus 6 times negative 3 fifths minus 10. This is going to be 9 25ths, but the 5 is going to reduce, so 9 fifths minus 18 fifths minus, and I'm going to put this as 50 fifths. 9 minus 18 is negative 9, negative 59 fifths. So our vertex is negative 3 fifths, comma, negative 59 fifths. And writing the vertex form, f of x equals, our a is 5, minus times x minus a negative 3 fifths or plus 3 fifths. I'm going to change that in a second. Minus 59 fifths. Okay. I'm actually fine with this final answer, but another way of writing this would be 5 times 5 plus 5x plus 3 squared minus 59 fifths. Okay. Or 25 59 fifths. All right, our vertex, we already have our, now I'm going to leave this then. Fifths. The shifting, horizontal, shift is going to be right 3 fifths of a unit, and vertical shift is down, and I believe that's 11 4 fifths, 11 4 fifths units. Okay, example 6, find the equation for the parabola that has a vertex of 1, 2 and passes through the point 0, 0. We need to know this in order to figure out our a value. So f of x equals a x minus h squared plus k. F of x equals a x minus 1 squared plus 2. Plug in 0 and 0, 0 for the x and 0 for the f of x. 0 equals a times 0 minus 1 squared plus 2. Our goal is to figure out what a is now. So this is just a plus 2. 0 equals a plus 2. A equals negative 2. So our final equation, f of x equals negative 2 x minus 1 squared plus 2. Alright, when can we use this stuff? We can use this for maximum and minimum type equations and situations where a being greater than 0, a positive number, then negative b over 2a is going to be a minimum value, the bottom of the U. If A is a negative value, then it's an upside down U, it's been reflected, then negative B over 2A is going to be a maximum. Either way, negative B over 2A is either the max or the min. Okay. So example 7, a baseball is hit 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees with respect to the ground. The path of the ball is given by the function f of x equals negative 0.0032 x squared plus x plus 3, where f of x is the height of the ball in feet and x is the horizontal distance traveled from home plate in feet. What is the maximum height reached by the ball? So the maximum height is going to be when f of x is at its max, or when we are at the vertex of this parabola, this upside down U-shaped parabola. So we need to find the vertex of the parabola, and we're looking for the f of x value being the maximum. That's the k value of the vertex. So let's find h comma k, and we're going to use the negative b over 2a. So h equals negative b over 2a, or negative 1 over 2 times negative 0.0032. And we're going to go to our calculators here. It's going to be a positive number. And I'll use my calculator. I've got 1 divided by 2 divided by 0.0032, and I have 156.25 feet. That is, so the h, or the x horizontal distance, h comma k is the x value. That's the distance away from home plate when the ball will have reached its maximum height. So now we need to know what is that maximum height at this distance away from home plate, or the k, or f of x value, or in this case f of h value, which is f of 156.25 value, which is negative 0.0032 times 156.25 squared plus 156.25 plus 3. So I'm going to square this value times 0.0032, but negative, and I'm going to add a 156.25 and 3, and I end up with 81.125 feet for the maximum height of the ball. Okay, and you have some IXL to work on and bookwork problems. That's it. Thank you very much. Bye.